Hello, my name is Peter. I'm the main developer of etherchain, the first Ethereum blockchain explorer. And today I would like to make a tour around the Ethereum blockchain, about how a blockchain explorer works, lining out some key statistics of the Ethereum chain, and later talk a bit about the scaling issues we have seen during the first month of this year. So, I'm sorry. So what is etherchain? etherchain is currently the second largest blockchain explorer. We serve around 500,000 users per month with 1.3 million page hits. We launched the first, let's say, alpha version of the explorer in 2014 actually, based on the Ethereum proof of concept 3 version. So it was quite early in the development of the software itself. And this makes it also one of the oldest projects still active. It was developed without any external funding. It started out as a hobby project and then matured several times, and is at the moment ad-free. The first version looked like this. It was a really simple website which already featured some of the key concepts of a blockchain explorer. So you were able to view the blocks, transactions, also contracts, and we even featured a compiler for the low-level, the Lisp-like language, sorry. This was built on proof of concept 3, which was a very raw version of Ethereum, and at that time only one client was available, the C++ client, and also a generic API to query this client was not yet existing. When the mainnet launched, we also launched a new version or a new iteration of the Explorer, which already featured several key indicators on the main page, showed the recent blocks and transactions. You see this picture was taken roughly 2.5 years ago. You see that especially from the price and also from the network difficulty, which were a bit different compared to today. And a few months ago, we released the third iteration of our interface that modernized everything a bit. We made extensive use of identicons to identify accounts, but kept the main principles the same. So how does a blockchain explorer work? And in fact, it's quite simple. We use an Ethereum node. Here we use parity because we found out it works better for our use case. And each Ethereum node provides a generic API to query its data, the JSON RPC API. We use this API to query the data, process it, and then save it in a structured way into an SQL database, which we then use as a basis for our web application to show blocks, transactions, statistics, and provide several tools as well. So which are the main challenges one faces when trying to build a blockchain explorer for the Ethereum network? First of all, accessing the so-called contract internal transactions is not really trivial. While it's easy to get information about the standard transactions, send some ether from A to B, it's much more difficult if a transaction invokes a contract and this contract then initiates one or several value transfers. Those events are not provided by the standard RPC API and need to be extracted via a special tracing API, which also now both clients provide by default. The same goes for decoding ERC20 or any kind of ERC transactions. Those are also not part of the generic JSON RPC API, and you need to decode them manually from the transaction receipts. Actually, right now, even completing a full node sync with this tracing functionality and archiving functionality enabled is quite a heavy task. It can take up to a week to sync it up. We managed to do it with some tricks in 3 to 4 days. Additionally, the blockchain is already very large, so there is a huge amount of data need to process, not quite in the big data level, but still not small, which means currently our database is around 600 gigabytes of data. And you need to really take care how you access this data. So each SQL query needs to be carefully optimized in order to ensure that you provide a usable and user-satisfying response time. And after that, the last point is also keeping up with demand. The Ethereum ecosystem experienced a tremendous growth during the last year, let's say. So we had to scale our system from like 23,000 users per month to now at around 500,000 users per month. The benefit of having the whole blockchain in an SQL data is it's quite easy to generate or retrieve relevant statistics of this data. So currently over 5 million blocks have been mined, and this totals to around over 2 sextillion hashes, which means over 2 sextillion iterations of the ETH hash algorithm. Over 155 million transactions were processed, and over 26 million accounts or unique addresses were generated or were active in on the blockchain. This means out of this 26 million, 22 were regular accounts, and the remaining 4 million are all smart contracts. So we have around currently 4 million smart contracts on the blockchain, and out of these 4 millions, we have currently 20,000 ERC tokens. Let's talk about the user statistics. So how does the typical Ethereum who is the typical Ethereum user? I see from the audience here this matches quite well. So most of the people that deal or interact with Ethereum are between 25 and 33 years old, and around 95% they are male, and with a main interest in finance and investment services. Where are these users located? We get a very good statistic from our sister site ethermodes, which provides network-related statistics of the Ethereum network. So how many Geth or parity nodes are on the network, where are they hosted, and how is also the version distribution of these nodes. Here we see that around 30% are hosted in the US. After that, we have around 15% in China, so there's a huge interest, and this also increased a lot during the last year. After that, Germany, then Russia, Canada, United Kingdom, and we see from the distribution of client versions, the gray bar here is Geth, and the green bar is parity, so around 60–65% of all nodes are Geth-based. If you look at the history of the daily number of transactions processed by the Ethereum network, we see that for the first few years it was quite in a very low range and experienced more or less exponential growth during end of last year, especially with the release of CryptoKitties, which really put a stress on the network, and also with the recent price increase. This is also always visible in the numbers of transactions. So now, right now, the storm seems to have calmed a bit, so transaction levels have also gone down. If you look at the daily Ethereum blocks, so how many blocks were mined on the network, we see that we can see some key events of the history of the blockchain. In the beginning, on the far left of the chart, which I see is not really visible, you see a huge spike of blocks mined. This was, let's say, the day the Genesis block was mined, where the difficulty was quite low compared to the hash rate in the network. Therefore, a lot of blocks were mined. Afterwards, we see a sharp decrease just a few weeks after, which can be attributed to a bug in the mining code of Geth, where each block that was mined had a timestamp exactly 1 second after the previous block. This means every miner running this buggy version caused the difficulty to increase and the block rate to decrease. With the first Ethereum hard fork, which brought Ethereum from a beta tool to be production ready. We saw also a block time decrease. So actually the block time was decreased from 18 to 19 seconds to 14 seconds. Later on, in mid of 2016, we see a, let's say, a fluctuation up and down. This is a result of the so-called Shanghai attacks, where the Ethereum network was put to under a DOS attack, which caused the block rate to fluctuate a lot. Then afterwards, the block time decreased, let's say, stepwise, which was an effect of the built-in difficulty bump that caused, that was included to, at some point, force a move to proof of stake by making it so very difficult to. Which one? This. Okay. Which was included to, at some point, force a move to proof of stake by effectively making it very hard to mine new blocks. And we see the stepwise decrease in the rate of blocks, and which was and the bomb was disabled during the last hard fork, which brought back the block interval to normal levels. And at the end of the chart, we see a high fluctuation again, which is a result of the scaling issues experienced during the last month, which I will be talking later a bit. In terms of network hash rate, there was only, since the launch of the network, only one direction, and this direction was up. So independent of, let's say, price and events in the ecosystem, the hash rate just increased. And today I had to update the chart from last month, and currently we are at around 255 terahashes per second, which corresponds in total to over 8.5 million GPUs mining actively on the Ethereum network. A month ago, it was only 7 million. So within 1 month, over 1.5 million GPUs were added. So how did the mining profitability look like during the history of the network? At the beginning, because of the low Genesis block difficulty, profitability was very high. What you see here is the daily return of a mining farm with 1 gigahash per second. This is not a small mining farm, but also not an exactly big one. And you see that the daily income fluctuates between around 300 US dollar and 39 US dollar. This is usually attributed to an increase in price. Hash rate follows price. So we see that when there is a huge increase in pricing, it takes some time for the hash rate to catch up. And during this time, mining is very profitable. When the price is declining or stable, usually the hash rate does not increase, what we saw from the previous picture, so the profitability is decreasing again. And right now we are approaching already again all-time low levels in regards to mining profitability. Let's talk a bit about decentralization. Currently we have around 40 to 50 unique miners, which means either solo miners or mining pools that are mining on the Ethereum network. At the beginning, there was around 10 times more unique miners on the network, which was, at that time, it was much easier to mine Ethereum from a solo, as a solo miner. And also, during the beginning, also mining pools were not existing. So it took some time for the first mining pools to appear, and this had then an impact on the number of unique miners on the network. In general, mining decentralization for the Ethereum network is not that good. Over 3 mining pools control over 60% of the Ethereum network hash rate as of now. Let's talk a bit about scalability issues. Between December 2017 and January 2018, the network was nearly to 100% utilized. This was again caused by the price increase, by the release of, and also by the adoption of a large number of new dApps. So how is the block, or let's say how is the block utilization defined? So for Ethereum, the protocol limits how many transactions can be included in a block. This is done by the mechanism of gas. Every transaction consumes a certain amount of gas. The simplest form, transfer ether from A to B, costs around 25,000 gas. Smart contracts execution can require much more. And then there is a limit on how much gas can be included in a block. The current block gas limit is at 8 million. This means that only around 380 transactions can fit into a single block. This causes, let's say, that makes an upper bound on the limit, on the amount of transactions that can be processed by the Ethereum network, which is at 25 transactions per second. But the block limit is not fixed. The miners, in fact, vote on the block limit, on the block gas limit, and in fact, it was also changed several times during the history of the network. At the beginning, the block gas limit was set very low to 5,000. This was the so-called thawing period, which was like a burn-in phase for the Ethereum network. At the beginning, it was then raised to 3 million, then later on to 4.9 million. And then we see a really sharp drop down. This was also a result of the Shanghai attacks that caused, where the block gas limit was artificially decreased by the miners to protect the network against these attacks. Because by reducing the block gas limit, not that many attacking transactions could be included in a block, and that made the attacking blocks less heavy to process by the clients. After the reasons for the attacks were mitigated, the block gas limit was increased again to 4 million, then later on to around 6.8, and now it's at 8 million. Actually, we can also see from the data from the blockchain how individual miners are voting on the block gas limit. By comparing the gas limit set on the current block to the previous block, we can see if they vote the block gas limit up or if they vote the block gas limit down. Currently, we see that most miners target now a block gas limit of 8 million. Some of them are still targeting a lower limit. So, in fact, what we saw also is that every transaction a miner increases also the chance of a block becoming an orphan. But compared to other blockchains, miners also get a reward for orphaned blocks, as they can be included in a so-called uncle block. But still, mining a large percentage of uncle blocks reduces the mining profitability, because uncle blocks do not get the same rewards compared to regular blocks. Furthermore, uncle blocks contain no transactions but still count towards to the network difficulty. So in fact, the more transactions a miner includes in a block, the higher for him is the chance for the block to become an uncle. We saw this a very extreme case during the Shanghai attacks, when certain miner decided to not include any transactions at all in the block. If every miner did this at that time, the network would have more or less stopped, blocks would still have been generated, but no transactions could then be processed. If we correlate the uncle rate to the transactions included in blocks, we see a really good correlation. So the higher the uncle rate, the more transactions are included in the block, and the higher the uncle rate of the network is on a given day. This data was gathered during the time when the network was nearly to 100% utilized. So which means as the Ethereum network approached 100% utilization, the uncle rate increased to 30%, which means 30% of, in fact, all mined blocks were orphaned. And as the uncle blocks count now after the last hard fork to the network difficulty, this in fact caused a reduction in total mined blocks and again less block capacity available to process transactions. So we see this in the next chart, where we have the number of mined blocks here and the uncle rate here. So during a period with a high uncle rate, also less blocks are mined, which causes again less space available for processing transactions on the blockchain. Fortunately, we did not hit, let's say, a feedback loop that this situation gets worse and worse and worse and worse. Processing 8 million gas blocks already consumes a lot of computing resources. On regular consumer hardware, parity is, or at least we got it, unable to process more than 2 to 3 million gas blocks per second. When syncing a new node, it takes more than 30 minutes to process then a single day of this heavy 8 million gas blocks. So if you want to sync up your node from the beginning, you have to plan quite some time to sync the chain. If now miners would increase the gas limit, this will further deteriorate the situation. More heavy blocks will be generated, they will be more heavier to process. And also a very high gas limit might open up the network again to DDoS attacks. And from my point of view, Ethereum should be in general still usable on consumer hardware, and you should not have to resort to high-end server hardware just to run a full node. So which solutions are there? So in the short term, for sure, efficiency improvements in the implementation. For example, TurboGeth, Alexei is doing a great job on this, optimizing Geth to be able to process transactions fast, blocks faster. Also, what we think can help is a relay network among miners to be able to distribute blocks and transactions faster to reduce further the uncle rate. Any change in the client implementation needs to be really adopted fast, especially by the miners and also by the users. And what always helps is a good guidance from the client developers how to run the software in an optimal way. For example, currently, most clients are, let's say, have sane defaults where they should work on any kind of hardware in some kind of way. It would be good to have like an indicator which parameters you can tune given your current state of hardware. But with these improvements, we might be able to double the gas limit. So in total, we will be able to process maybe 3 million, 4 million transactions per day. But at some point, any current improvement will not bring a big, let's say, improvement in general. So in the long term, we have to look at different scaling options like sharding, plasma chains, or payment channels. Just some tips when the network is highly congested, it's always a good idea to consult the so-called gas price oracle for the most suitable transaction fee. Etherchain provides an oracle, but there is also, I think, one built in the coming version of MyCrypto, and also there's ETHGas Station, which was mentioned in the talk before. Furthermore, if a transaction, it's always good to remember that if a transaction gets stuck because you set a too low gas fee, you have the possibility to resend the same transactions with a higher gas price by defining, by using the same so-called nonce value. This is a good way, let's say, if one of your transactions is stuck, to get it unstuck and send it again. So, last point, messages on the blockchain. The Ethereum technology contains, let's say, several methods how traditional messages or text messages can be included. Those messages were included, let's say, in the during the first 40,000 blocks, where it was still not possible to send any transaction. So actually in the first block, or one of the first blocks, because actually the first Ethereum block had also 8 uncle blocks with a number 1. And this message was included in one of those uncle blocks. It was Yates Randall with Ether Ninja. At block 18, somebody included that Bitcoin is the blockchain, which is now here forever. Then we see some German messages, sinnlos im Weltraum, or keep in Bewegung halten, keep on moving. Then the first marriage proposal was at block 90,852 by Mr. Riegel, and the first advertisement on the Ethereum chain was at block 26,000 for that the ethereum.co.uk address is for sale. Furthermore, messages can also be included in the transaction input field, so everybody can include arbitrary data in the transaction input field, and here we find lots of messages distributed on the chain. Somebody proclaimed that Franco is freedom. We have a quote from Albert Pike. Somebody wanted his money back. The full Hackers Manifesto is on the blockchain. Limev greeted his mom, and the last and maybe one of the, let's say, well-known messages that what is included that way was the message Fahrt nach Hause, which means go back home, which caused all Geth nodes to crash and started the so-called Shanghai attacks. So what we have planned for the future on etherchain, what we would like to do is so-called solidity function fingerprinting, which allows us to decode transactions without, or to show the function call executed by a transaction without having the actual source code available. We plan to release an ERC token explorer, a dedicated browser for the ENS, the Ethereum name system, and the JSON RPC proxy API, which you can use to broadcast your transactions. Furthermore, we have 2 open source projects we maintain, so if you need to run your own blockchain explorer, we provide the so-called etherchain Lite, which is available on GitHub, which is a browser dedicated for testnets and your private Ethereum networks. And there is also a dedicated ERC20 explorer, which can be used to create an explorer for a token that was developed. So that's the end of my talk. If you have any questions, I will be happy to answer them. Thank you. Right now, we don't have any real plans to monetize it. The operational cost is not that high at the moment, so for us currently there is no need to put any kind of monetization efforts on it. The token explorer we already show all token balances on the site, so you will see in addition all the transactions that were executed, plus the standard functions of the smart contracts that were behind them. So you have the approve function and the transfer to function calls and things like that, and we plan to adopt it also to new token standards that are being developed right now. I mean, we have these 2 open source projects that should fit in this category. So if you want if you develop an ERC token, you want a dedicated explorer for that, you can use our ERC20 explorer, which is already released on GitHub. And if you need an explorer for an Ethereum network, your private testnet, or you can also hook it up to the mainnet, you have access to etherchain Lite. Which replicates, let's say, 90% of all the functionality the full version provides. And the benefit is for etherchain Lite, for example, you need no backend software. Etherchain Lite connects directly to a parity node and retrieves all the relevant information from the Explorer directly from the node. So it's quite easy to set up and easy to integrate. It works also, it works with both nodes, it works with Geth and with parity, but we developed it mainly for parity.
Wait a bit, the micro is needed for the streaming. Where's the question?
What about the part about the parsing to Postgres? Because even if you run etherchain Lite, then probably the performance of some of that would be terrible.
Yes, if you run it on the mainnet, it will have, on certain accounts, it will have problems. When certain accounts that have a lot of transaction history, they make problems. But besides that, if you don't really navigate now to the Poloniex account or to the Bittrex account, you won't see any issues with the Lite version. Did that answer your question, or sorry?
I actually meant if there's a possibility for etherchain Lite for you to be able to parse that information into Postgres as well, or is it only on demand and that then takes a lot of time?
You mean to use Postgres as a, let's say, storage layer for etherchain Lite or something in this, or?
Yes, so the way that you showed that you actually use for your site.
Mm-hmm. Now, let's say we have no plans to open source the full code right now. We might be thinking about that in the future, but it's quite, let's say, a lot of work has been put into that, and it's quite heavy to maintain for us, in addition, the full version to these two open source projects. And it's also not really a trivial way to run the Explorer. With etherchain Lite, we provide a really an easy way to get 90% of the functionality of the whole site at reasonable performance, let's say.
I was wondering, can you describe your DB setup? Because you said like you have 600 gigs of data.
What you mean exactly with DB setup?
Which DB you use?
We use PostgreSQL. We host it on Amazon, and we focus mainly on optimizing data storage and having optimized queries to process or aggregate data in a fast and efficient way.
Will etherchain Lite possibly use some of the tracing for internal transactions at some point?
Yes, it has full tracing integration. It has full source code upload integration, so it will actually decode Solidity function calls. So it has all these features covered.
And what testnets are supported by default, I guess?
All that are supported by the clients. So whatever testnet parity or whatever testnet Geth supports, it's supported by etherchain Lite, and I think it's also included in the PubF test framework or development framework by default. Okay, thank you very much.